Mind reading, the ultimate superpower. Being able to tap into someone's thoughts, emotions, and desires without them saying a word. It sounds like science fiction, but it's a concept that has fascinated humans for centuries. But with rapid advancements in technology and neuroscience, the question on everyone's mind is, will we be able to read minds in 2025? Despite the excitement, we have to acknowledge that we're not quite there yet. Currently, neuroscience and technology are facing significant limitations that make mind reading seem improbable. For instance, our brains are incredibly complex, and the neural networks that govern our thoughts and emotions are still not fully understood. Moreover, even if we did understand the brain, we'd need a way to decode the neural signals, which is no easy feat. Additionally, the technology to read and interpret these signals is still in its infancy, not to mention the ethical implications of being able to read minds. It raises a plethora of concerns about privacy and consent. Another major hurdle is that our brains are uniquely wired, making it challenging to develop a one-size-fits-all solution. What works for one person may not work for another. Furthermore, even if we could develop a universal solution, we'd need a way to distinguish between different types of brain signals, for example, separating thoughts from emotions or memories. To make matters more complicated, our brains are capable of producing an incredible amount of data, and processing that data in real time is a monumental task. The sheer scale of the problem is daunting, and it's easy to see why many experts believe that mind reading is still a pipe dream. However, despite these challenges, researchers are making incredible breakthroughs in brain-computer interfaces and neurotechnology. Companies like Neuralink and Kernel are working on developing implantable chips that can read and write neural signals. These advancements have the potential to revolutionize the way we interact with technology and even treat neurological disorders. For instance, brain-computer interfaces are already being used to help paralyzed patients communicate, and researchers are exploring their potential in treating conditions like depression and anxiety. In addition, scientists are also exploring the potential of electroencephalography, or EEG, to decode brain signals. EEG is a non-invasive technique that can detect electrical activity in the brain, and researchers are using it to develop systems that can recognize specific thoughts or emotions. While we're still in the early stages, the possibilities are endless. Imagine being able to control devices with your mind, or communicate with people without saying a word. One particularly compelling example is the work being done by researchers at the University of California, San Francisco. They developed a system that uses EEG to decode brain signals and translate them into spoken language.